Hey everybody, I figured I would give you a video overview of kind of how I would structure a game in PyGame. I've already kind of talked about it a little bit, but I figured that an example would be helpful. So all I did here was I took the template and then used that to build my game. So before anything else, let's go ahead and launch the game. This one is mouse input. This is the one for actually next week where you're going to use mouse input, but I'll go ahead and just show it, because it's pretty much the same. I just updated the zombie one to use the mouse. So press space, and as you can see, I'm clicking, and there we go. I can hit C to continue, and there we go. You'll see there's more zombies. Based on that, it's keeping track of my score and my lives. You'll notice every time I finish a level, my lives will go up by 1. Also, the number will increase. I can move around like this if I die. Notice that the zombie that kills me will be teleported to the bottom right. That is to stop it in case I get hit up here in the top left. If I don't move the zombie, then I will respawn and just instantly die and lose all of my lives. So let's go ahead and get killed so that I can show there's the end screen. You can hit R to restart or escape to quitted. I need to fix that. Hit R to restart, and it looks like I need to fix that because it looks like it's not resetting the level, so I need to fix that. Okay, but I'll fix that later. So that's what the game looks like. Nothing special, but it's a little bit more than what we've done thus far. So let's look at the template and how that applies to the game. So I'm just importing PyGame, sys, random, and platform. Those are the 4 packages I'm using, and then I'm getting the local variables from pygame.locals. That is used for down when you're checking for events, so you can check if event type is quit or something like that. That's what that's for. In the init section, first thing you always want a pygame.init, and then you set up any type of globals you might need. So for example, this one I'm setting a width and a height in a window. Using that width and the height, I'm setting 2 colors, so those are the only 2 colors that I'm using. I'm setting up 2 fonts, again, those are the only 2 fonts. Then I'm setting up 3 sprites, the survivor, the zombie, and the bullet. And you'll notice over here in the file structure, I have those inside of an images folder just to help me stay organized. And I'm importing them from images / whatever they're called. So projectile, survivor, and zombie.png. And I'm doing convert alpha. And then down here, I'm checking the operating system to set the key repeat values so that like how often, like if you hold a key down, how quickly it is repeated. That is because the way PyGame works on macOS versus Windows, the key repeat is very, very different. At least it was last time I tried to do this on Windows. It's been about a year or so since I've actually done it on Windows, so this may not even be necessary anymore, but I don't have a Windows machine to test it on, so be it. If somebody can let me know whether these key repeat values are just bonkers or something, let me know. And then that's it for the init. All I did was init PyGame, create a bunch of globals, and then set the key repeat. The next section is state. This is, again, I've been harping on state for weeks now, and I'm going to continue to do so because state is a very important concept in programming in general, but especially in games as well as in like web programming or things like that, or application programming. State's very important. I personally, in PyGame, like to create a state class. The reason for that, creating a class instead of using a dictionary, is because it lets me use dot notation, so I can use like state.running instead of state open bracket, open quote, running, close quote, close bracket. It's just a little bit quicker and easier to type, especially considering that I have a JavaScript background where you use dot notation for that kind of stuff, for objects. So it just makes it easier for me. You don't have to use a class. You can use a dictionary, or you can actually do it the right way and create a whole state machine, but that's kind of outside the scope of this class and this video. In my state, I have several different variables. I have running, which is just whether or not the game is actually powered on. So like if the application is open, I want running to be true, and then as soon as running is no longer true, I want the application to actually close entirely. Current scene is just what it sounds like. That's the screen. You might hear this called sometimes, but scene is kind of the convention. It's going to start off at title, but it also has game and end. Later on, I might add a pause. I might add a menu screen, so like if I wanted to let you buy new guns or upgrade your survivor in some way or the other, something like that. Then I'm setting a timer. Those are the 3 that you should have in pretty much every game you ever create. And then you have the other things. I have the 3 different groups I'm using. I'm using the all sprites group, which is all it's used for is rendering So I just basically says all sprites group dot draw, and it'll just draw everything to the screen. The zombies group is where all the zombies are in, and that's used for checking for collisions between the player and for bullets and for other zombies. And then I have the bullets group, which is also used for checking collisions. Then I have some state variables that will change, such as lives, score, and level. So the player starts off with 3 lives with 0 score, and they start off on level 1. The level is used for the number of zombies to be populated. I want to say it's just 4 times the level, but so on and so forth. Gun limit frames is used to make it so that if you hold down the shoot button, it doesn't just spit out a new bullet every single frame and just clobber everything and make the game way too easy. Player speed and zombie speed. I was toying around with the idea of allowing players to increase their speed with upgrades, or the zombie speed might increase as the levels go up, so on and so forth. So those are just things to keep track of. So that's my state. Yours will probably look different, although it should start off with these. You should have sprite groups. You'll probably have lives and score and level. You may not. And then whatever else you may need to keep track of goes in your state. This is all just setting stuff up and keeping track of it. Scene functions. Then I have one function for each scene. So I've got the title scene. I have the draw scoreboard, which is actually just kind of called inside of draw the game scene. I just separated it out, but just to make my life easier and help kind of keep separation of concerns. So the scoreboard, all it does is it draws the score and the lives. You saw that in the bottom left and bottom right. And the draw game scene just fills the window with black, draws all the sprites, and then on top of that draws the scoreboard. That order is important because if you do scoreboard first, before the sprites will be on top of the scoreboard. And that may be what you want, but I wanted the scoreboard to be on top of everything else. And then draw the end scene. You'll notice this is an if statement. The end scene is going to be different based on if the player still has lives or not, because the end scene will be drawn after all the zombies are dead or after the player runs out of lives. So if the player still has lives, that means they survived, they killed all the zombies, so we want to give them a different interaction, a different experience than if they died. So if they survived, and they kill all the zombies, then it says you survived the night, you've killed this many number of zombies using the score from the state, and then it gives them options to C to continue, R to restart, or escape to quit. Same thing if they died, but it says you were eaten, and it says, again, you killed this many zombies before you died, but then they don't have the option to press C to continue. They can just restart or press escape to quit. And then after determining which one of those to draw, it actually draws them. Fills the screen with black to overwrite whatever's there, and then blitz all 3 of those to the screen. Those are my scene functions. Notice, these are just functions. They don't do anything by themselves. You have to actually call them. This is something that a few people are still struggling with. Functions are just blocks of code that you create and you package up into this nice little function, but they don't do anything unless you actually call it. So here's some helper functions. Fix out of bounds just checks if things go off the screen, and if it does, it moves them back on the screen just to stop them from going off the screen. Create player does exactly that. It creates a new player, pushes that player onto the all sprites group, and then returns that player. This is not a necessary function, but I found myself creating a player several times, and I don't like to repeat my code because I want to have very dry code, so I went ahead and broke it out into a function. This right here, this image, I could, because the player image will always be that survivor, I almost just left that out and only did the X and Y coordinates, but I decided to leave it in case I wanted to allow the player later on to change the look of their survivor. If I wanted to have a survivor with different hair colors or with different skin colors or with different clothes or whatever, I wanted to have that option open. Create zombies, all it does is just exactly what it says. It's a for loop for I in range, whatever the level is times 4. So in other words, get the level, multiply by 4, and create that many zombies. It gets a random position for the X and the Y that will never be more than 100, because that way it kind of moves it down away from where the player spawns, because if the player spawns at the top left, it moves it 100 pixels away from that player as the minimum. And then it moves it 48 away from the right and bottom edges of the screen, just to kind of keep them positioned in the box about like that. And then it sets the speed, which is again a random int, so that you have zombies moving at different speeds, but it's a random int between positive and negative, whatever their speed is. And then it creates a new zombie using those, pushes that zombie to the zombies group, and then pushes that zombie to the all sprites group. So the zombies are, each zombie is in both groups, both the zombies and the all sprites group. The next level function basically is used to transition from the end screen after the player has won to the next screen. It kills the player sprite because we want to respawn them in the top left instead of where they are currently located. Then it kills any remaining zombies. This shouldn't ever happen because the only time I'm ever calling next level is if there are no more zombies, but just to be safe, just to be sure. It gives them an extra life for completing that level. Then it creates new zombies, creates a new player, and then finally, after doing all that, updates the current scene to be game. It's because it's going to be the end screen, and then we're changing it back to game so it actually displays all this stuff. Reset is very similar to that, except it kills the player, kills the zombies, and this one actually matters because reset will be called after the player loses oftentimes, so there will still be zombies remaining, and if you don't kill them, then you'll have more zombies than you should when you start the game. Then we reset the state, the lives, and the score. We create new zombies, create a new player, and then set the scene to game. So this one is very similar to this one, except that it resets things back to the starting position instead of kind of a continuing position. Those are all my helper functions. And then the next section is classes. This is where I created classes for each of my sprites. I just have 3. I have the player, I have a bullet, and I have zombies. If you wanted to, you could have multiple enemy types. They could inherit from zombie, or they could be different. You could have multiple bullet types, like if you had rockets, or if you had maybe like a 3-burst thing, whatever. You could create different bullet types if you wanted to. But for player, you have to have the dunder init, where the first part you call the supers dunder init, and super is whatever you're passing in here. And for PyGame, it's going to be pygame.sprite.sprite with a capital S. And then inside of the init, you tell it what parameters it's going to take. This one is going to take an image file, which is survivor, an xstart, and a ystart. All of those have defaults, so you don't actually have to pass them in as long as you want those default values. Then it sets the image to the image. It sets the rect to the rect of that image. So we're just going to take that image and then get a rect for it. And then it sets the xstart and the ystart to whatever you pass in. So this is just creating a new player and populating the starting variables. Then this player has 2 methods attached to it. It has move and it has shoot. Move takes one parameter, whatever key is pressed, and if the key is up, then it just moves the rect up. If it's down, it moves the rect down, left and right, so on and so forth. This is so that whenever the player presses the key, I can just call move and pass in that key, and I don't have to worry about checking all this stuff in my while loop down below in my main game loop. I can just call player.move. Same thing with shoot, except that what shoot does is it first off, it gets the X and Y right here. And honestly, I didn't need this. I made this to make my life a little bit easier. And then now we get into a bunch of math because we need to figure out the trajectory of the bullet because this is a mouse one. The one you're currently on is not a mouse one. You're just going to use keyboard input and shoot it in a direction. So you really don't need to do all this math in yours. But next week, when we get into mouse input and you're shooting with the mouse, you will need to do some math to normalize the vector. There's a lot of different ways you could do this. I am not a math genius. These type of things, this whole geometry thing and linear algebra kind of confuses me a bit because, as I've mentioned before, I'm an English teacher. And my math, when it comes to much beyond regular algebra, is shaky. But I was able to figure it out. And what this does is this makes it so that it doesn't matter how far away from your player you click, your bullet will always go the same speed. Because when I first did it, if you clicked close to the player, your bullet moved pretty slow. But if you clicked far away from the player, the bullet moved really fast. And we don't want that. We want it to move the same distance or the same speed regardless of how far away you click. So this normalizes the vector and makes it so that it will always be the same regardless of how far away you click. And then we create a new bullet. New bullet equals a bullet, calling this class, passing in the X and Y, the BMX and the BMY, and then adding it to the all sprites group and adding it to the bullets group. Notice that I just created a function for shoot instead of having to do all this mess down in my code, in my while loop. And then I created a class for bullet, which, again, the dunder init is pretty much the same. For the move, the bullet is always going to just move its speed in whatever its direction is. And then I had something here, and I included this in the move. So after moving, it also checks if it's off the screen, because I want to make sure that I destroy my sprites if they're no longer being rendered to the screen, if they're no longer needed, so that we don't have a memory leak or anything like that. So as part of the move function, because I knew I would be calling this every frame, because once you shoot a bullet, it's going to move every single frame. It's never going to just stop. I just included it in here instead of having to call it separately. So it just checks if it's off the screen, and if it does, it kills it. Then another one is checking if it's collided with something. All this does is just check if rect.collide rect with whatever sprite you pass in. This is not really needed. You could easily do this function because it's just a one-line type thing. I mean, you could easily do this function in your while loop in your code, but this just helps my brain. It helps me helps me work with my code better. And I mean, if you're like me and you're like that, there's nothing wrong with doing it that way. I created a zombie. Dunder init is pretty much the same. Its move is basically the same as the bullet, where you just move the speed, same as the player move the speed, except that instead of checking if it goes off and killing it, it checks if it bounces, if it hits the border, and then it bounces. It changes the direction based on whatever border it hits. And then down here I checked collide. If it collides with another zombie, it reverses its direction, both its X and its Y direction. This is very similar to bouncing off the borders. I could actually have just put this inside of the move now that I'm thinking about it. That probably would have been even a little bit better, and I can update that in a future version of this, because every time it moves, we want to check if it collides with an enemy sprite, so I could definitely do that. So that's the classes section. I only have 3 classes: player, bullet, and zombie. And then we get into the main function. Your main function, you always want it to be named main, lowercase m. And at the very beginning of the main function, before your main game loop, you have to initialize whatever variables you're going to need that you haven't been able to initialize yet. I chose to name the window inside of here. We're going to name it Tay Zombies version 2. I created a player, and I created zombies, because you want to do that whenever your game starts. Whenever your game gets going, you want to go ahead and create whatever you're going to need. And then as soon as that's done, we start the main game loop. Notice that this is not while true, this is while state.running. If you'll remember, state.running up here starts off as true, but we can easily set that to false later on in order to break out of this loop. So I'm going to jump down to the end of this loop real quick so you can see what's going to happen after state.running is set to false. Jump down to the end. The only thing that happens is it runs pygame.quit to quit the pygame, and then it runs sys.exit to quit the actual Python function. I pass in a 0 because it means we're quitting and everything's working fine. So the first thing in my main game loop is to tick the timer. That's the very first thing you should do in your main game loop. And then I have my if statements to check what scene I am in. So immediately after that, I'm running if statements. If the scene is title, do something. Else if the scene is game, do something. Else if the scene is end, do something. And that's really all that's in there other than the pygame.display.update. So inside of my while loop, I want to say that again. I'm taking my timer, the first thing. The last thing, I'm updating the display. And in between there, the only thing is an if statement checking the current scene. Now, inside of those current scenes where all the magic happens, you're not going to put any of your game logic outside of these if statements. The reason for this is, like, let's say that I'm processing events or I'm checking for the win condition. I only want to do that when the game itself is actually going on. I don't want to check for a win condition inside of the title screen. That doesn't make any sense. I don't want to check for a win condition inside of the end screen. I don't want to move zombies inside of the title screen. That, again, doesn't make any sense whatsoever. So all of your game logic goes inside one of these if statements, one of the whatever appropriate if statement it is. So in this one, I have 3 scenes, so I have 3 possible choices. If current scene is title, do this. If current scene is game, do this. If current scene is end, do this. And notice that it's an else if. That's not strictly necessary, but it does make your program slightly more efficient. So if it's title scene, we're going to call the draw title scene function. That's the first thing we're going to do, because we're going to draw it to the screen first, and then we're just going to wait for player input. And it's important that you keep in mind that this whole loop is running every single frame over and over and over and over and over again. And the way that if statements work is if it matches the current condition, if this condition is true, then all it does is run this, and it does not even check these else ifs if they're true or not. It skips over them and just runs the bottom. So during the title screen, all that's happening is this code is running every tick, every frame, and then we are updating the display, and then it is jumping back up and running it again. So this is all that's running while the current scene is titled. We're drawing the scene, and then we are listening for events. So for event in PyGame event.get, in other words, get all the events, get the pressed keys, and if the event.type is quit, what that means is that you clicked on the X or the red circle if you're on Mac, or pressed pygame.k_escape means if the escape key is in that pressed list, because pressed right here is a list of all the pressed keys. So if either of those things are true, if you click the X or you pressed escape, set state.running to false, which, as we talked about earlier, will just shut everything down. Else, if you press space, set state.current scene to game. That's all this does. This is why the current scene is so cool. We don't have to write a bunch of transition logic in here inside of this if statement right here. We don't have to add a bunch of crap in here that tells us, okay, now you want to create your player, now you want to set up your zombie, now you want to do this. All you have to do is change the current scene. And what that does is tells this, okay, don't do this anymore, start running this one. Because now on the very next tick, the very next frame, it's going to jump back around to the top of this while loop, it's going to tick the timer, and then previously it's been running this, but because our current scene is no longer title, it's going to skip over this and come right down to here and run everything within this code block. And this is one thing where I don't like Python. I don't like the indentation having meaning, but it's part of the language. It's been part of the language since the beginning, so you just have to kind of get over it. So now every frame, this code is running. All of this is running. And then after it's done, it skips over that, updates the display, jumps back up to the top, ticks the timer, skips over that, runs all this again, so on and so forth. So the first thing we're doing is we're going to draw the game scene, and that's just drawing it on the board. Notice, as I mentioned before in the previous lecture, not in this video, but your scene functions, all they're doing is drawing. Notice the draw game screen, all it does is draw stuff. It doesn't update the position of anything. It doesn't have any logic in it other than maybe the end screen that checks which one to draw. It doesn't move stuff. It doesn't kill zombies or create zombies. All it does is draw. So it fills the window with black, draws all the sprites, and then draws the scoreboard. That's all it does. So down inside our main game loop, game scene. So we're drawing the scene first, and then after that's done, you do all the steps of your game. I like to check for the win condition first. The reason for that is that in case there's something that comes down where you have two events, a winning event and a losing event happening at the exact same time, the very next frame, I want to give the player the benefit of the doubt, because players want to win, and you want games to be fun. Games are more fun when you are able to overcome things and win things. So I want to, if there's ever a time that happens, that's very rare, but if there's ever a time that happens, I want the player to win. I want to give them the benefit of the doubt on that one. So first, check to see if they win. If they win, in other words, if there's no more zombies, if the length of the zombies group is 0, then you go to the next level, and your current scene goes to the end scene. And again, what that does is that makes it so that none of this code runs, and it just starts running the code down here. And then after we check for the win condition, we're going to process our events like we did before. So if they're going to try to quit, set state.running to false. Else, if they click the mouse and the gun limit frames equals 0. We haven't talked about gun limit frames yet, but we will in a second. So if they click the mouse and the frame limit is 0, then they're just going to shoot, state.player.shoot, and all I'm doing is calling that function. And I'm updating the gun limit frames to 1, plus equals 1, but updating that to 1. The gun limit frames is just a timer, basically, that limits them to only being able to shoot every 10 frames. Otherwise, they could just spam out bullets, and it would just be super, super easy to win. The other thing that I'm doing is if they press A, S, D, or W, then I'm calling player.move, passing in that pressed key. So if they press A, it's going to pass in pygame.k_A. If they pass in S, if they press S, it's going to pass that in, so on and so forth. And it's just going to call the move function using that. So after processing the input events, we need to do the fire rate limitation. This is where we're starting. Oops, I have a typo. TH. This is where we're starting the timer. So if 0 is less than the limit frames is less than 11. In other words, if it's somewhere between that, if it's between 1 and 10, increase it by 1. So if it's at 1, go to 2. If it's 2, go to 3, so on and so forth. And this is running every frame. So as soon as you shoot, the player shoots, it moves it to 1, which means that this will now work. This will now start doing. In every frame, it'll increase it by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once it gets to 10, it'll go up to 11. And then once it gets to 11, this will no longer go because it's no longer less than 11. And instead, else if it's greater than 11, reset it to 0. And at 0, it will stay because this only runs if it's greater than 0 but less than 11. So if it's at 0, it will never increase until the player shoots. Once the player shoots, it gets increased to 1. Actually, I could just set this equal to 1 to make life a little bit easier and possibly cut down on a bug. And that's what that does. That just limits how quickly they're able to shoot. Then we want to move the zombies. This is very simple. For Z in the zombies group, Z.move. Same thing with the bullets. For B in the bullets group, B.move. The reason this is super simple is because I set up the move methods in the classes. This allows me to keep my while loop a little bit more clean. Then after doing all that, we want to check to see if the player died. We're going to check each of the zombies in the zombies group, and if the player's wrecked collides with the zombie, player dies. So we're going to kill the player. Remember that .kill is a PyGame method that basically just means remove it from all groups so that it's no longer drawn to the screen. Then we want to decrement their lives by 1. If their lives are still greater than 1, in other words, or greater than or equal to 1, if they still have lives left, create a new player up in the starting left corner, and that zombie who killed them, this Z right here, needs to be moved all the way down to the bottom right. The reason for that is because if the player's sitting up in the top left and he gets hit by a zombie and dies, that zombie is still going to be right there when the player respawns, and then the player will die again and again and again and instantly lose all their lives. That's no fun for anyone. So if the zombie hits them, I just teleport the zombie down here. There are better ways to do this, nicer ways to do that. You could make the player invulnerable for a certain amount of frames, or you could kill the zombie if you wanted to, or you could change the zombie's direction so they moved away from the player. There's a bunch of different ways you could handle that. I just went with the simplest way. And then if the player lives are not greater than or equal to 1, in other words, if they're out of lives, set the current scene to end. And then, after checking to see if the player dies, we're going to check if the zombie is killed by a bullet. So for zombie in the group, and then inside of there we're doing another for loop for bullet in the group. So for each zombie, check each bullet. And if the bullet is collided with the zombie, kill the zombie and increase the score. Same thing with the zombies. For Z in the zombies group, for Z2 in the zombies group, in other words, check this same group twice, but just check if those two things are collided with each other. If they are, reverse their positions using that Z.collide. And again, I could have put this inside of the move method inside of the zombie class, and actually I think I will do that when I do an update to this, if I do an update to this. And that is the game logic. That's all of the logic for that game inside of the game scene. And that will just run on a loop infinitely until either the player dies, runs out of lives, or kills all the zombies. Once one of those two things happen, you'll notice that the state is set to end, either there or up here. That's the win condition. Once that happens, it'll break out of this loop and hit this one. And it will just keep running this over and over and over and over and over again until you do something else. So we're going to draw the end screen and then just listen for keyboard events. Right here is checking is if you're doing quit the thing. Now here's what's interesting. If you push C, C is for continue. C is what's going to happen if after you defeat the zombies and you want to go to the next level. I'm checking for the C. I'm also checking if event type is key down and state lives is greater than 0. These two are both very important. Let's talk about this one first. I only want the player to be able to hit C if they have lives left. If they're out of lives, that means they lose and they have to either quit or reset. They can't go to the next level. They've lost. And if I didn't check for that here, the players could be able to hit C and just go on and continue even though they died, and they would just continue. Now this event type equals key down. This is important because the event will do both for key down and key up, and it also has repeat, so on and so forth. So what I was finding happening is that when I pushed C, if I didn't just instantly let off of the C, and if I held it down for a second, next level would actually trigger twice. Now this generally doesn't matter, except it would give me 2 lives instead of 1. So I had to check and make sure the event was just a key down, not a key up or a key held or whatever like that. That way it limits it to just running once. So that's why I did that. So if you run into that problem where events start firing twice or something like that, consider checking for a key down. And then else, if they hit R, run the reset function. And that's it. The very end is call main, and this is just a copy paste. If dunder name equals dunder main, run your main function. And that is it for all of this code. This is 300 some odd lines, 395 lines, so almost 400 lines of code to make a game that's actually playable and is actually kind of fun and kind of challenging. It's not going to really hold your attention for an extended period of time or anything, but thinking back to some of the like old Apple II games or things like that, this isn't far off from those. You would need a little bit more some more depth to it, probably different enemy types, maybe upgrades for the player, maybe some obstacles on the screen to shoot around or run around or hide behind or whatever. Maybe some better AI where the enemies actually track the player or move towards the player. Maybe that might be just a special enemy type that's going to move towards the player instead of bouncing around randomly. I don't know. There's a lot of different design decisions you can make. But this is an excellent proof of concept of how you could make this type of it's a top-down shooter, basically. So hopefully this helped you understand the whole structure of the code a little bit better, especially the if statements inside the main game loop. That seems to be the section where several people are not quite understanding the purpose of them or how they work. This is how they work and why they work like that. This is the best way to structure your main game loop scene decision tree. Think about it kind of like a decision tree where it's one of these scenes, because you can only have one scene showing at a time. You can only have a title screen or a game scene or a game over scene or a menu or a pause or whatever. You can't show more than one of those at a time, so that's why you're using these if statements to determine which one to show. As always, if you have questions, let me know. I'm happy to help. Thanks.